Hello everybody, I am here with my new video on chemical calculations. Let's start. In this video, we will focus on problems involving chemical equations. Our first problem related to mole problems. In the equation N2 plus 3H2 arrow 2NH3, how many moles of N2 are needed to produce 5.0 mole of NH3? Solution. From the equation we know that 1 mole of nitrogen produces 2 mole of ammonia. We can solve it using FLM means factor level method. Our solution map is as follows. 5.0 mole NH3 arrow equation coefficient mole N2 question mark. The solution is as follows. Mole N2 is equal to 5.0 mole NH3 multiplied by 1 mole N2 divided by 2 mole NH3 equal to 2.5 mole N2. Our next problem is related to mass problems. To understand this, we will solve the following problem. In the equation CH4 plus 2O2 arrow CO2 plus 2H2O, how many grams of CO2 are formed when 8.0 grams of methane reacts with an excess of oxygen? We will solve this problem using FLM. Here equation is given in moles, not grams. So first we must convert moles into grams. Here is our solution map. 8.0 gram CH4 convert into mole CH4, equation coefficient mole CO2, and then we will convert this mole CO2 into gram CO2. The problem is solved as follows. Gram CO2 is equal to 8.0 gram CH4 multiplied by 1 mole CH4 divided by 16.0 gram CH4 multiplied by 1 mole CO2 divided by 1 mole CH4 multiplied by 44.0 gram CO2 divided by 1 mole CO2 equal to 22 gram CO2. The term excess in the problem statement means that we have more than enough oxygen to react with methane. Therefore, the mass of carbon dioxide will be produced depends solely on the quantity of methane present. For this reason, methane is called a limiting reactant. At the end of all, the CH4 will have been consumed and some of the oxygen will remain unreacted. Reactant that is not present in excess and is entirely consumed in a reaction is called limiting reactant. We now focus on technique which allows us to determine which reactant in a reaction is present in limiting quantity on next slide. Let us consider this equation N2 plus 3H2 arrow 2NH3. Suppose 2.0 moles of N2 and 2.0 moles of H2 are brought together to react. Which of the reactant is present in a limiting quantity? Calculate the mole ratio of reactants in the problem. Mole ratio from problem, we have 2.0 mole of N2 and 2.0 mole H2. So ratio would be 1.0 mole N2 and H2. Now we calculate the mole ratio of reactants as they appear in the reaction. Mole ratio from equation is equal to 1.0 mole N2 divided by 3.0 mole H2 is equal to 0.33 mole N2 divided by 1 mole H2. Conclusion. We now compare the mole ratio. If mole ratio from problem is greater than mole ratio from equation, then reactant in the numerator is in excess. Here it is nitrogen. If mole ratio from problem is less than mole ratio from equation, then reactant in the denominator is present in excess. In this problem, mole ratio from problem is greater than mole ratio in equation, means N2 is in excess and hydrogen is the limiting reactant. The next question we need to ask is what quantity of nitrogen will actually react? Solve this problem using FLM. Mole nitrogen reacting is equal to 2.0 mole H2 multiplied by 1.0 mole N2 divided by 3.0 mole H2 is equal to 0.67 mole nitrogen. Therefore, we conclude that 0.67 mole nitrogen will react and all 2.0 mole of hydrogen will be consumed in this reaction.